Hello there guys, and welcome back to another epic inexorable maths video. In this video we're taking a look at integrating x to the power of n with respect to x. In order to do this we need to recall that the derivative of x to the n is n times x to the n minus 1, okay? I have a video showing why this is true that I will leave a link to in the description. Make sure that you're very happy with basic differentiation before you have a crack at integration, because integration and differentiation are intrinsically linked together. They are inverse operations. So differentiating and then integrating, or integrating and then differentiating, you can think of as almost the equivalent of timesing and then dividing, or dividing and then timesing, or adding and then subtracting, or subtracting and then adding. You're just undoing what you've done. So adding 5 and then taking 5 away to something, it just takes you back to where you started, right? Integration and differentiation are kind of like that. So if you integrate something and differentiate it, you get back to where you began. Okay, so we want to find what the integral of x to the n is with respect to x. That's the question, that's what this video is about. How do we do that? Well, what we do is we need to think very carefully about a function that its derivative is x to the n. That's what we want to do. What function differentiates to x to the n? Well, to differentiate x to the n, you times by the power and then you take 1 off the power. What if we did that backwards? What if first we added 1 to the power? So let's say x to the n plus 1. And then what if we then, instead of timesing by the power, what if we divided by the power? Because this is the opposite of differentiation. So you're doing the opposite things. You're not taking stuff off, you're not timesing, you're adding stuff and dividing, and you're doing it in the other order. So you're dealing with the power first and then doing the timesing or dividing. With differentiation, you times first and then you take 1 off the power. What we're going to do is we're going to add 1 to the power and then divide. And when you do any integral, you always add a little plus c on the end. That c is just an arbitrary constant. It can be any constant. That's always there for indefinite integration. That means when there's no numbers at the top and the bottom of the integral, okay? So how do we know that this is correct? Because it looks like it might be right, but how do we know? Well, if you don't know whether you've integrated something correctly, you can check that you've integrated correctly by seeing what happens when you differentiate that new thing. The reason why this works is because, again, integration and differentiation are inverses, which means if you have integrated something, if you differentiate it, if you've integrated it correctly, you should get back to where you began. You should get back to the function that is inside of the integral there that hasn't been integrated yet. So if we differentiate, let me write this again. So 1 over n plus 1 times x to the n plus 1. I hope that we agree that these are equivalent. Okay, well, I'm just, instead of writing it as x to the n plus 1 over n plus 1, I'm writing 1 over n plus 1 times x to the n plus 1. But they are the same thing, I'm just writing them in a different way. So we can clearly see the coefficient is 1 over n plus 1. So using the rule for differentiation, which we can see here, what we do is we times by the power. So to differentiate this, and I'll write this here, to differentiate this, we times by the power. The power is n plus 1. So we do n plus 1 over, and then there was already an n plus 1 there, so n plus 1. And then we have an x to the power of 1 less than what you started with, right? So what's 1 less than n plus 1? Well, it's just n, isn't it? And the plus c disappears in any case. You can put a plus c in here as well. It disappears because it's a constant. Constants differentiate to 0, so it does disappear. So we can say that's equal to this. And again, just to simplify, n plus 1 divided by n plus 1 is simply 1, of course. So you get x to the n on its own, which is what we have here, which means that we can be very, very, very happy that the integral of x to the n with respect to x is x to the n plus 1 over n plus 1 plus c. Okay, this is the power rule for integration. Thank you guys so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.